Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. So in this video I am describing a solution of an ideal diesel cycle. So let us see one of the problem for the diesel cycle. So here from the data, an engine operating on an ideal diesel cycle has a maximum pressure of 44 bar and a maximum temperature of 600 centigrade. The pressure and the temperature of air at the beginning of the compression stroke are 1 bar and 27 respectively. Find the air standard efficiency of the cycle and take gamma equal to 1.4. So this example that will be into Gujarat Technological University in June 2010 for 7 marks. So starting with the PV diagram over here. So x-axis that will be representing as a volume and y-axis that will be representing as a pressure. Now according to the data that will be give a ideal diesel cycle. So you can see that according to the theory of the diesel cycles, that will be constant pressure heat addition process. So in that case for 1 to 2 that will be adiabatic compression. So here PV raised to gamma equal to constant for 1 to 2 process, and after 2 process to 3 process that will be constant pressure heat addition. So P2 that should be equal to P3 over here, and according to the first positions that will be P1. So after 3 point, once again it will be the adiabatic expansion process. So just you can see over here PV raised to gamma equal to constant. So 3 to 4 process representing as a adiabatic expansion process as from the diesel cycle, and once again for 4 to 1 process that will be constant volume heat rejection take place over there. So once again that will be come into the state number 1. So for the constant volume, or you can say V1 equal to V4. So according to all the 4 points, P1 V1, P2 V2, P3 V3, P4 and V4. So in that ideal cycle you can see that P2 equal to P3 and V1 equal to V4. So let us see the which kind of data is given to us over here. An engine operating on an ideal cycle has a maximum pressure of 44 bar. So just you can find from the figure, or you can say PV diagram. So maximum pressure it will be P2 equal to P3, that will be here equal to 44 bars. So 44 into 10 raised to 5 pascals. And a maximum temperature of, so that will be T3 point, so that will be representing as a maximum temperature. So T3 equal to 1600 degree centigrade, or you can converting into the Kelvin, so 1873 degree Kelvin. Now the pressure and the temperature of air at the beginning of the compression are, so beginning of the compression that will be representing as a state number 1 positions. So P1 that should be equal to 1 bar, so 10 raised to 5 pascal, and T1 that is the temperature over the point number 1, and that will be 27 degrees centigrade, so that should be converting into 300 Kelvin. Now according to the diagram, just you can see that from a PV diagram of 1 to 2 process, or you can say adiabatic process. So in adiabatic process there is a temperature and pressure relationship. So T2 upon T1 that will be equal to P2 upon P1 raised to gamma minus 1 upon gamma. So just you can put the value of T1 from here and P2 and P1. So that will be, you can finding a T2 temperature, that will be your 884.46 Kelvin. So now we are assuming that the 1 kg of mass, so similarly P1 V1 equal to mR T1 relation should use it, and assuming the R is equal to 0.287, so here V1 equal to 0.861 meter cube. After 2 to 3 process, just we can find over here. So as per the adiabatic process, P1 V1 raised to gamma equal to P2 V2 raised to gamma. So V1 upon V2 equal to P2 upon P1 raised to 1 upon gamma. So V1 upon V2, here we are that V1 upon V2, it should be called as a compression ratio for the diesel cycle over here. So finally you will get the R is equal to 14.92, and that will be representing as a compression ratio. Now I am interested to finding a cutoff ratio. So as from the definition of the cutoff ratio, we already seen into the theory lectures. So that should be equal to V3 upon V2, and it will be converting into T3 upon T2 because of the constant pressure process. So 1873 divided by 884.46, so you will get the cutoff ratio equal to 2.11. Now the main question is what? Find the air standard efficiency of the cycle. So here it will be like equations 1 minus 1 upon R raised to gamma minus 1 in bracket cutoff ratio raised to gamma minus 1 divided by R into gamma rho minus 1. So we have the compression ratio, cutoff ratio, and the value of gamma, and that will be 1.4. So just put the value and you will get the answer. So here it will be the air standard efficiency of this diesel cycle, that will be equal to 59.77. So here it will be the simplest steps up to identifying a ideal diesel cycle efficiency. So if you like it, then subscribe, share. Mechanical Magic, Mechanical Learning Tutorials. Thank you very much.